Hi, this is Nimla Rednam. In this video, we are going to continue solving the Class 10 board paper that was conducted on 17 February 2026. We started the basic paper set 2 and so we are going to continue that. We covered section A which has 20 MCQs. Let's continue and do section B. Here you have 5 very short answer type questions. Each carries 2 marks. So let's look at the 21st question. If A, comma 0, B, 1, comma 1 and C, 0, comma B form a triangle right angled at B when joined, then establish a relation between A and B. Right? So we are starting section B. 21st question. Okay. I'm going to draw a right angle triangle. Okay. Right angle at B, right? It's given as 1, comma 1 and A is given as A, comma 0 and B is given as 0, comma B, right? Now, I want a relation between these two variables A and B. Now, clearly when you look at a right angle triangle, we know that you can always use Pythagoras theorem, right? In order to establish the relation. So what is the Pythagoras theorem? AC square, that is hypotenuse square, is equal to AB square plus BC square, right? Now AC square using distance formula, if you look at the difference of x coordinates, it's A, so you'll get A square plus the difference of y coordinates is B, so I'm having B square, right? Is equal to, now if you look at A, B square, the difference of x coordinates is A minus 1 and I have to square it, and difference of y coordinates is 1. Square of it is 1 again. Now BC square similarly is going to give you 1 plus B minus 1 whole square. Now if I expand this, I have A square minus 2A plus 1 plus 1 plus 1 plus B square minus 2B plus 1, right? So I can cancel A square and B square on both sides. I have 2A and 2B. I'm going to take it to LHS is equal to 4, implies A plus B is equal to 2. This is the relation between A and B. Now there's another way of solving this using the slopes of the lines A, B and BC, because we know that AB is perpendicular to BC. You can find the slope of A and slope of slope of AB and slope of BC and say that the product of the two slopes is equal to -1 since they are perpendicular to each other. I want you to try using this method as well. Okay, slope method. Right. Next question, 22nd question. In the given figure, right? In the given figure, triangle ODC is similar to triangle OBA if angle BOC is 110 degrees, angle ODC is 45 degrees and AB is equal to 2CD, right? AB is equal to twice of CD. Then find the angle OAB and also the ratio OB is to OD. Now let's draw the figure and then we'll proceed with the solution, right? 22nd question. I have it's parallel, right? And the ratio AB is twice of CD, right? So something like this. AB is twice, right? So this is my CD and this is my AB. AB length is twice of CD, as you can see, right? Now I have this angle is given as 110 degrees and this is given as 45 degrees. Okay, this is 45 degrees. Now they're asking us, and also it is given that AB by CD is equal to 2. Okay. Now how do I find the measure of angle OAB? This is the angle that I'm interested in, right? So you can see that here, if this is 45, because this is parallel to this. So if this is 45, these are interior alternate angles. So this is also going to be 45 degrees, right? Now if this is 45 and this forms a straight angle, AC is a straight line. So if this is 110, this is going to be 70. Okay. Now in one triangle, if I know two angles, I can definitely find out the third angle, which is the required angle. Let's call it theta. So theta is equal to 180 minus 70 plus 45, which is nothing but this is 115. So that will give me 65 degrees. So that is the measure of angle OAB. That is your first bit. In the second question, they're asking us OB by OD. Now you can see that if you consider triangle COD and triangle AOB, okay, OB by OD is nothing but one of the ratios of the sides, and clearly here you can see that we have to look at the similarity of the triangles because we are talking about ratio of corresponding sides. So these two triangles are similar. How do we know that? This is vertically opposite angle. If this is 70, this is also 70. And as we've already seen, these are alternate interior angles and these two are of equal measure. And so I have two similar triangles, COD and AOB. Now, when you are applying, when you are going to use this similarity in order to find the ratio of the corresponding sides, you should be very careful with the corresponding sides. So here, I want OB by OD, so I'm going to write down first OB by OD. So OB is opposite to theta here, right? OB is opposite to theta, right? And here, if this is theta, then in this triangle, this is theta. So what is the side opposite to that? It is OD. So I have two sides opposite to 65 degrees that we just found out as one ratio. Now this is equal to, in this triangle AOB, we already know AB by CD is 2. We know the ratio, right? So we are going to use that. So here I will write AB, okay, and then corresponding to this, again here this is the 70, so by CD, right, which is given by in the question itself as 2. Therefore the ratio that they're asking, which is OB is to OD, is also 2. That is your answer, right? Let's go to the 23rd question. Evaluate 5 sine square 45 minus 3 tan square 30 divided by 2 secant square 30. So if we know the values of these trigonometric angles, then we can simply substitute the values and find the answer, right? So what is the first one? Sine 45. We know that sine 45 is 1 by root 2. Next is tan 30. We know that tan 30 is 1 by root 3. And the next is secant 30. Secant is simply reciprocal of cos, and cos 30 is root 3 by 2. So it is 2 by root 3, right? Now let's substitute the values. I have 5 times sine square, so half, minus 3 times tan square, which is 1 by 3, whole divided by 2 times secant square 30, which is 4 by 3, right? So this is nothing but I have 5 by 2 minus 1, which is 3 by 2, okay, into this will give me 8 by 3 in the denominator, so it will become 3 by 8 when it comes to the numerator, which is nothing but 9 by 16, and this is the required answer. There is an internal choice here. So let's look at the next question in 23rd. This is the A bit. Let's look the choice question, B bit. For A 60 degrees and B 30 degrees, verify that tan A minus B is equal to tan A minus tan B by 1 plus tan A tan B. Again, this is also substitution of the trigonometric, values of the angles that they have given, right? So A is given as 60 degrees, B is given as 30 degrees. So A minus B is nothing but 30 degrees, right? So here LHS is tan A minus B, which is nothing but tan 30, which is 1 by root 3. Now let's look at the RHS. RHS is tan A, which is tan 60 is root 3, minus tan B 1 by root 3 by 1 plus tan A into tan B is 1, right? So this will give you 3 minus 1, 2 by root 3, right? So this is again 1 by root 3, which is nothing but LHS. Therefore, we have verified that tan A minus B is indeed tan A minus tan B by 1 plus tan A tan B. That is the 23rd question. Next, let's look at the 24th question. If HCF of 135x square plus 180, sorry, not plus. If the HCF of 135x square and 189x cube is 108, then find the value of x. So here, right. So let's write the two expressions that they have given to us. 135x square and 189x cube. Alright. So because we have to find the HCF, which is highest common factor, we need to first factorize these two. Let us use prime factorization. Now for 135, we know that if you do the prime factorization, you're going to get 3 into 3 into 3 into 5, right? And there are 2x, so x into x, okay? And for 189, clearly 3 is going to work, again 3, and there's 1, 7. So it is 3 into 3 into 3 into 7 into 3x, x into x into x, right? Now here I want to find the highest common factor. Clearly in the numerical part it is this, right? HCF is equal to 3 cube, which is nothing but 27. And in the variable part I have 2x here, which is common, and an extra x, so x square. This is the HCF. Now they're saying that this is given as 108. From this we can find out x, right? X is equal to 108 by 27 x square, which is nothing but 4. So x is equal to 2, right? So this is the value of x. So the next question, 25th question, is on probability. Find the probability that a number selected at random from the numbers 30, 31, so on up to 60 is a prime number, is the first part, and the second part, the probability that the number is a multiple of 6. So in probability, what do we do? We have to write down the favorable events, and then we are going to count the favorable events and the total number of events and find the ratio, right? So first of all, we are considering numbers from 30 to 60. So because in the first bit we are talking about a prime number, let's list down the number of the prime numbers between 30 and 60. So 31 is a prime number, next is 37, next is 41 and 43 and 47 and 53 and 59. These are all the prime numbers in between 30 and 60. So as you can see, if you count, there are 7 of them, right? There are 7 of them. So the probability that the given number is prime is 7, which is the favorable outcome by total. How many numbers do we have? 30 to 60? We have 31 numbers. So the answer is 7 by 31. Next is, what is the probability that it's a multiple of 6? Now 30 is a multiple of 6, 6 into 5, right? And 60 is 6 into 10. So clearly in between you have 6 into 6 and so on. I have 4 more in between. So total I have 6 multiples of 6, right? So the probability that a given number is a multiple of 6 is 6 by 31. So this is your answer to the second part. There is internal choice in this. So let's look at the B question, B bit. Slips of letters of the word are put in a bowl. The word is background and thoroughly mixed. One slip is picked up at random. Find the probability that picked up slips letter is, first case I have to find the probability that it's a vowel. In the second case I have to find the probability that the it is present, the slip that you have picked up, that letter is present in the word ball. Okay, so let's look at the first part first. So this is the choice question B, and I'm going to look at the first part of this. Now when you look at the word background, the favorable event that I'm talking about here is that it's a vowel. So you know that A is a vowel and I have O and U. So 3 favorable events. Probability that it's a vowel is 3 by, what are the total number of events that you pick up a slip, and it can be any of these 10 letters. So 3 by 10 is the probability that it is a vowel. Next they say, what is the probability that it is present in the word ball? Now what are the letters in the word ball? B, A and L, right? So L is not possible because L is not present in background, but B and A are possible. So the favorable events here, okay, probability that it is present in the word ball, the favorable events are 2, right, out of total number of events, which is 10, which is nothing but 1 by 5. So this is the probability that the slip that you have picked up, it has a letter which is also present in the word ball, B-A-L-L, right? So with this we finish section B of the paper that we are solving. So the next section, section C, has 3 questions and 6 3-mark questions. Each question carries 3 marks and there are 6 questions. Let's quickly look at them. 26th question. Find the zeros of the polynomial p of x equal to 4x square minus 8x plus 3 and verify the relationship between its zeros and coefficients. So there are 2 parts to it. First you have to find the zeros and then you have to verify the relation between the zeros and the coefficients, right? So let's write down the polynomial. Section C, I have 26th question A. The given polynomial is 4x square minus 8x plus 3, right? So here you can find the zeros by using factorization or the formula for the roots, which is minus b plus or minus square root of b square minus 4ac by 2a, right? So if I factorize this, the product is 12 and the sum is minus 8. So I can write it as minus 6 into minus 2, right? So you can factorize it like that, or you can use the formula like I mentioned, right? This is nothing but 2x minus 1 into, you have 2x, you have taken out 2x minus 3, right? So implies x is equal to 3 by 2 or 1 by 2. These are the zeros. Now the second part is verify the relation between coefficients and the roots. You know that a equal to 4 in the standard form, b is equal to -8 from the given polynomial, and c is equal to 3, right? So I know that sum of the roots is minus b by a, which is 2, and product of the roots is c by a, which is 3 by 4, right? Let us verify. Now here, sum of the roots is 3 by 2 plus 1 by 2, which is indeed 2. Okay, so hence verified. Product of the roots is 3 by 2 into 1 by 2, which is 3 by 4, which is also holding the ground. So we have verified both the relations that we have between the zeros and the coefficients. The internal choice question is form a polynomial whose zeros are alpha square and beta square, where alpha beta are zeros of the another polynomial that is given to us. Okay, so first of all, what we are interested in is forming a polynomial whose roots are alpha square and beta square. So if the roots are given to us, we know that the polynomial is x square minus sum of the roots, which is alpha square plus beta square, x plus product of the roots. So here, what do we know about alpha and beta? Alpha and beta are the roots of the another polynomial, which is given by x square minus 3 root 2x plus 4. So from here, I know that alpha plus beta is 3 root 2 and alpha beta is 4. Now from this clearly it is obvious that alpha square beta square is 16, right? So this we are going to be using, and using these two can we find alpha square plus beta square, because once I have that, I know my polynomial q of x, right? So alpha square plus beta square is simply alpha plus beta whole square minus 2 alpha beta. I know that this is 3 root 2, right? And I know that this is 4. This is nothing but 36 minus 8, which is 6, right? And 9 2s, sorry, it's not 36. 9 into 2 is 18. 18 minus 8 is 10, right? So I have alpha square plus beta square now. Therefore, the required polynomial q of x is simply x square minus 10x plus 16, okay, equal to, this is the required polynomial, right? So this is how we are going to find a polynomial whose roots are alpha square and beta square, right? So this is 26th question. Let's move on to 27th question. Prove that root 2 is an irrational number, right? So here we are going to prove this by contradiction. That is, we are supposed to prove that root 2 is irrational, okay? So I'm going to suppose it is rational, okay? Suppose root 2 is rational. Then by definition of a rational number, I can write root 2 as a ratio of p by q, okay? In its simplest form, q not equal to 0 and pq is 1. That is, there is no common factor between p and q, right? If root 2 is rational, then I can write it in this term, right? Now, if I take it further, I can write p as root 2 q. Now, if I square it on both sides, I can write p square as 2q square. Now, because this entity here is 2 times of something, I can say that p square is even. If square of a number is even, then definitely p is also even, right? If p is even, then I can write p as 2 times of r, right? Implies I am writing p as 2 times of r, okay, which is equal to root 2 q. Now again squaring on both sides, I have 4 4r square is equal to 2q square implies q square is equal to 2r square. Okay, again by same logic, q square is even, which implies q is even. Now if p and q both are even, then they definitely have a common factor. All even numbers have a common factor 2, which is a contradiction, because we're saying that in the beginning we have clearly mentioned that p and q do not have any common factors other than, right? So because of this contradiction, our assumption that root 2 is rational is wrong. So proof by contradiction, root 2 is irrational. Okay, so this is your 27th question. Next, let's move on to 28th question. How many terms of the AP 3, 5, 7, 9 so on must be added to get the sum 80? Okay, so the AP is given to us. This is 28th question. Okay, from the AP I know that the first term is 3 and the common difference is 2. Okay, so they're giving us the sum as 80, right? And we know that the formula is 2a plus n minus 1 into d by 2 times n. This is your sum of n terms of an AP, right? So I'm going to substitute here. 2 times a is 6 plus n minus 1. N I am supposed to find out, times 2, right, times n. So this is nothing but 2n plus 4 times n, which is nothing but 2n square plus 4n. Okay, so here I arrive at a quadratic 2n square plus 4n minus 8 equal to 0, or n square plus 2n minus 40 equal to 0, right? Sorry, here I have to take by 2, right? So here I have divided by 2, right? So here it is n square plus 2n minus 80. Okay, here it will be n square plus 2n minus 80 equal to 0, right? So now I'll write it down neatly again. N square plus 2n minus 80 equal to 0, right? So here if you look at the product, it is minus 80, and minus 80 can be written as 10 into minus 8, which gives the sum 2. So the factorization will give me n plus 10 into n minus 8 equal to 0. I have to take the positive value because we are talking on number of terms, and negative value has no meaning in this particular context. So the sum of the first 8 terms is going to give you the sum as 80, right? So now the internal choice question B is 3 consecutive terms in AP whose sum is 21 and product is 231. So whenever they're talking about 3 consecutive terms in an AP, usually we are going to take the 3 terms as A plus D and A minus D, right? Why do we do this? So that the simplification becomes more elegant. Now the sum is given as 21. Now you can see that D gets cancelled when you add these 3, okay? And the sum becomes 3A. 3A equal to 21 implies A equal to 7, right? And then I have product is given as 231. So what is the product? A minus D into A plus D is equal to 231. This is the product. Now I know that A is already 7. So when I take that value into consideration, I have 49 minus D square is equal to this. I'm going to take to the other side and it will give me 33. Implies d square is equal to 49 minus 33, which is nothing but 16, implies d is 4. So this is the common difference. Since they're asking us to find the three terms, the middle term is already 7, we know, and plus 4 will give me 11, minus 4 will give me 3. So these are the three terms of the AP. Now let's look at the next question. In the given figure, chord AB of a circle subtends an angle of 120 degrees at the center O of the circle. Find the length of arc AB if radius of the circle is given to us. So we know that length of the arc is given by the formula L is equal to R theta, right? So this is 29th question. Let me draw the figure. I have a circle centered at O. AB is the chord which subtends an angle of 120 degrees, right? Now, length of AB, L is equal to R theta, right? Now, what is the radius given as 21 centimeters? And what is theta? Theta is 120 in degrees. I have to convert it to radians. So, I'm going to write it as into pi by 180. And the units is centimeters, right? So if I simplify this, so this will give me 2's, 3's, 3 7's. I have 14 pi, 14 into 22 by 7, right? 7 1's, 2's. So this is nothing but 44 centimeters. This is the length of the RAB. Right. Next question. Prove that tan square theta plus cot square theta plus 2 is equal to secant square theta cosecant square theta. This is from trigonometry. And whenever you have to prove a relation between trigonometric terms, usually, let me write down the question, tan square theta plus cot square theta plus 2 is equal to secant square theta cosecant. So whenever you have to prove something like this, always start with LHS, keeping RHS in mind, because ultimately you have to, that is the destination, you have to reach there. And also always it is going to be elegant to use the trigonometric identities that we are familiar with, right? So here I have tan and cot squares of them in the LHS, and you can see that I have secant square and cosecant square. Clearly I know a relation between tan square, secant square, and similarly cot square and cosecant square, right? So I'm going to start with LHS, okay, and use the identity that I'm familiar with, which is tan square is simply secant square minus 1. Cot square is simply cosecant square minus 1. We are already seeing the terms in RHS, right? So, right, and then this gets cancelled. So now I have secant square plus cosecant square. However, I want the product, not the sum. So here we might have to use the other identity, sine square plus cos square equal to 1. In order to use that, I'm converting this into sine and cos, right? And take the LCM. Now you can see that already I have what I require in the denominator. When I take it to numerator, it becomes a required RHS. And in the numerator, I have sine square plus cos square, which we know by identity that this is equal to 1. Therefore, this is 1 by sine square cos square, which is the required RHS once I write it in the reciprocal terms. Secant square cosecant square. Right? Hence proved. So this is your 30th question. Next, let's go to 31st question, the last question in section C. Points P 6, 0, Q 2, 8 and R minus 2, 4 are vertices of triangle PQR. It is given that MN is parallel to QR such that PM by MQ is 1 by 3. Use distance formula and ratio formula to show that Mn by QR is equal to 1 by 4. Now here when they say something like use this formula in order to find out or in order to prove something, you have no other option, or usually you have many ways of solving the same problem in mathematics, but when they say use, there's nothing more to think about it. You have to simply blindly follow the instruction. So here they're asking us to use the distance formula and the ratio formula. So in coordinate geometry we know the distance formula. If x1, x2 and y1, y2 are the points, then distance formula is, I'm going to write down x1, y1, x2, y2, and distance formula is square root of x1 minus x2 whole square plus y1 minus y2 whole square. So we'll be using this, right? And then what is the ratio formula? You know that the point which divides something in the ratio of m is to n, okay? If the point P is dividing this line joining x1, y1 and x2, y2 in this ratio, then the coordinates of P are given by mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, internally of course, and in the figure you can see that it is the ratio formula that we need to use is internal because the point is in the m is in between P and Q. So let us draw the figure quickly. I have P, Q, R, M, N, and this is parallel, and 6, 0, 2, 8, minus 2, 4, right? And I have to find Mn by QR. So because they're saying you have to use distance formula and ratio formula, we know that you have to find the points m and n using ratio formula and then find the distance between m and n, right? So QR, let us first find out QR, which is difference between 2 and minus 2 is 4, right? 4 square is going to give you 16, and y2 minus y1 is again 4 square 16 square root, which is nothing but 4 root 2. So denominator is already known to us. Now in order to find mn, first I have to find m and n. So m divides pq in the ratio of 1 is to 3, right? So m is 1, n is 3, and I'm going to find the coordinates. M, which is 1, x2, which is 2, plus n, x1, which is 6, by m plus n, which is 4, and again m, y2, which is 8, and n, y1, which is 0, by m plus n. So this is simply 2 plus 18 is 20 by 4 is 5, right? And 8 by 4 is 2. This is my point M. Now let's find N. Similarly, you can find N as 1 M into x2 minus 2 plus N into x1 by M plus N. Okay. And I have M into y2, which is 4, and n into y1, which is 0, by m plus n. So on simplifying this, I'm going to get 18 minus 2 is 16, by 4 is 4, okay, and 4 by 4 is 1. So these are my 2 points, and from this I can find mn as x2 minus x1, which is 1, 1 square is again 1, and 2 minus 1 is 1 square. So root 2 is mn, right? Now here, when we were finding n, and I'm using the same ratio m is to n. See, the explanation here which has to be mentioned is Mn is parallel to Qr. That is why if this ratio is 1:3, this is also 1:3. Okay, that is how we conclude that m is to n in this case, Mn and here are also 1 and 3, right? If they don't give that information, we wouldn't be able to infer the ratio in which n divides Pr. Okay, now I have Mn also. Therefore, Mn by QR is root 2 by 4 root 2, which is 1 by 4. So that is the required ratio. However, in this question, I would like you to just look at the question, read the question, and try to find an alternate solution to it which does not use distance formula or the ratio formula. Simply using basic proportionality theorem and the fact that Mn is parallel to Qr is sufficient for you. We don't even need the coordinates of the points PQR. Without using distance formula or the ratio formula or the coordinates of the points PQR, you can still get this ratio Mn by QR simply using basic proportionality theorem. I want you to think about that alternate solution, and you can ask any doubts if you have in the comment section, or give the solution in the comment section. However, it won't work in the exam because they have clearly mentioned that you have to use distance formula and the ratio formula. So with this, we finish section C of the paper. Next, we are left with section D, right? And which has 4 questions, and section E, which has 3 questions, which I'll be covering in the coming video.